We're going to go over just how to get started on the limiting reagent problems. Now, number one, we did this in class, so in your notes. Period two, I think, was pretty close to this, but most of you have done number one, so I'm going to skip that one for now. I'm going to start with number three here, so you can work number one the same way. So we've got this reaction, magnesium and hydrochloric acid. So it says, what volume of hydrogen at STP, okay, is produced from the reaction of 5.00, that should be grams, that was a mistake, of magnesium, and the equivalent amount of HCl. Well, okay, you got 75 grams of HCl. They're being kind of technical there, but that's what you got to work with. So what's the volume of hydrogen? That's what we're trying to find. So I'm going to come up here and circle that on there. We're trying to find hydrogen gas. And we are given, okay, now we got two givens, 50 grams of magnesium and 75 grams of HCl. So two ways you can do the problem. You could do this problem by making this your given and then seeing how many grams of hydrogen chloride you get, of hydrogen. Then you can do a second equation. You can start with 75 grams of HCl, see how much hydrogen is formed, and whichever one is most, that's your limiting reagent. But I'm going to start here. Let's see. We've got 50 grams of Mg. I'm going to find out which one, how many moles we have. That's the first step. Now, on the periodic table, we need to know the molar mass of magnesium. And magnesium is 24 grams per mole. 24 grams of magnesium is in 1 mole. So I can tell here I've got almost probably a little bit over 2 moles on there. And now I'm going to see what we have of the other given was 75 grams of hydrogen chloride, HCl, hydrochloric acid. And let's see, chlorine is 35, hydrogen is 1, so the molar mass for HCl is going to be 36 grams of HCl. Oh, didn't mean to go off the page there. Is going to be 1 mole of HCl. That cancels out, that cancels out. Well, 36 goes in there about 2 times. So you're going to end up having more or less about, actually, I think 36 and 36, actually a little bit more. I think we're going to end up with the exact same amount of moles of these two over here, which is going to be, I'm going to say about 2. You're going to have to do the actual, it's going to be 2 point something and 2 point something. So they're really close. I'm not going to give you that. So now the next step, we got to look at the balanced equation at the mole ratios. So for magnesium, there's 1 mole of magnesium in the balanced equation. And then for HCl, there's 2 moles of HCl. So in order for this reaction to work properly, you need to have twice as much HCl as magnesium. Now here's what we got though. We've got, it turns out, just about a little over 2 moles of each. So we got the same amount of moles of each. But in order for the reaction to go nice and smooth, we need to have twice as much hydrochloric acid as we do magnesium, and we don't have that. We've got 2 moles of magnesium, we've got about 2 moles of this. This turns out to be our limiting reagent because we would need to have twice as much in order to use up all of this. So I'm just going to label this is limiting, because according to the ratio of 1 mole of this to 2 moles of this, whatever our moles of this is, you need twice as much, which should be about 4 moles. Now, given that, now that we know that HCl is our limiting reagent, okay, that should be now your given. 75 grams of HCl over, let's see, 1 mole of it. Well, at that point now you're just doing a gram to gram conversion. So I'm going to stop right there. And the other one, if you'd have worked out, if you'd have started this and ended it with a full gram to gram, you would have found out you would have had twice as much of the reactant from this problem, which means, excuse me, you would have had more of this one. My mistake. You'd have had half as much. This would have been the limiting one. Let's see. How much of the excess reagent is left over from problem 3? Well, let's see over here. Since we need to have twice as much of this as we do that, and we don't, we're only going to use half of what we got over there. So we're probably going to end up with about 1 mole of this once you work it out. You'll have to show the math there. All right, number 5. What's the maximum number of grams of copper sulfate that can be formed? So that's what we're trying to find. Copper sulfate, find. Can be formed when you have 80 grams of copper, reacts with 25 grams of sulfur. So first off, we need to find what the limiting reagent is. So let's see, I'm going to start with 80 grams of copper. Cu. And when you look on the periodic table, the molar mass for copper is we'll round it to 54 grams. 54 grams of copper is 1 mole. And we'll see what that is. And then we're going to do 25 grams of sulfur. 1 mole of sulfur is going to be, well, let's see how heavy 1 mole of sulfur is, 32. 32. Well, I'll actually work this one out because they don't quite, this one's going to be a little less than 1. This one's going to be a little over 1. So let's see what we got. We got 80 divided by 54 equals, we're going to have about 1.48 moles of this one, of copper. And we have clear, definitely going to have a lot less, clear all there. Let's see, 25 divided by 32 equals 0.78 moles of sulfur. Now, at first glance, it looks like this may be our limiting reagent, but you have to look at the balanced equation ratios. In this equation, we have 2 moles of copper, 2 moles of copper for every 1 mole of sulfur. I'll just put 1 mole S there. What am I doing? So let's see. According to this, we need to have twice as much of this as that. And I think we got it. 0.78. Let's see. I think that's going to be just about twice. Let's see. 0.78 times 2 equals 1.56. Okay. This is almost twice as much. So what that's going to tell us, since we only need 1 of these, this one turns out this is going to barely become our limiting reagent because we would really need to have 1.56 moles of this chemical to be able to react with that. So copper is our limiting reagent. So when you go to do your full-scale stoichiometry with that, you're going to start with 80 grams and convert that into how many grams of CuS is formed. Okay, so there's getting started on those. What we can do here is, all right, that's enough for this.